Anjali and my topic is database management system. Today our topic is Armstrong axioms. Coming to functional dependency, Armstrong axioms are the inference rules or secondary rules. So in Armstrong axioms we are having three types: reflexivity, augmentation and transitivity. Where if y is a subset of x, then x tends to y. Here x is the determinant, whereas y is the dependent. So here x tends to y is the functional dependency. Where coming to augmentation, if x tends to y, then xz tends to yz. Here we are adding z attribute. Here z can be any attribute or set of attributes. So we can add to the left side and right side. So xz, yz. Then it is also the functional dependency. Next, transitivity. Transitivity is nothing but x tends to y and y tends to z. Then it will give the x tends to z is the one functional dependency. Here same y is repeated in first statement and second statement. So we are combining those two. So it will result to x tends to z. Okay. All these will be useful in normal forms. And later we are having union, decomposition and pseudo-transitivity. All these are also inference rules. Whereas union, we are combining x tends to y and x tends to z, which gives x tends to yz. Here coming to decomposition, x tends to yz. We are decomposing the tables. We are splitting the table into two parts. So x tends to y and x tends to z. So based on the decomposition rules, we will split the data into two tables. Pseudo-transitivity. Pseudo means it is the just we are assumption. We are taking the assumption, and if x tends to y and yz tends to xz, then same repeated will be y repeated. So xz tends to w. Okay. Forms A0. Normal forms, it should be well-structured format. So it should be minimum redundancy. Replication of data should be minimum. Have to reduce the redundancy and have to allow the users to safely insert, update and delete the records in a table. Okay, so we are avoiding the anomalies. Next, normal form is nothing but it is a state of creation obtained by applying some rules. We give the rules regarding particular normalization and we will do in a stepwise. So in the conclusion we will obtain the normalization. And normalization is nothing but it is the process of decomposing a relation. So we are splitting the data into sub tables based on the rules. We have to apply the rules. Based on rules we have to split the data. So and we have to avoid the anomalies. That is normalization. Coming to first normal form, each attribute must be atomic. Atomic is nothing but it should not contain multi-values. So if student having multiple courses, they have to give in separate records. It should be given in separate records. And no repeating columns within a row. To first normal form, we are having two tables here. First one is the unnormalized table. And second one, after the normalization, we are getting the first normal form table. Okay? In the first table, unorganized table, we are having the attributes employee number, name, department number, name and skills. In that we are having each ID. Here they are doing different skills. So C, Perl and Java, they are doing in employee number 1 is doing these 3 and 2 is doing Linux and Mac. Whereas 3, DB2, Oracle and Java. So here multi-values occur. It is in unnormalized form. So we have to convert into first normal form. We will divide each record into particular record and we will assign each course in one. If you observe for one employee number, we are giving the skills separately. C, Perl and Java in different records. Okay? Like that. Second one also employee number 2 also we are giving Linux and Mac in separate records. Next third one DB2, Oracle and Java. Like that we are avoiding the anomalies here. We are decomposing like that to achieve first normal form. Coming to second normal form, it should be, we should avoid partial dependency. Okay, each attribute must be functionally dependent on the primary key. So each attribute should be